First of all, my name is Greg Miron, KJ6CR, Kilo Juliet 6 Echo Romeo, and I'm here to talk about my homebrew antennas. I started doing this about 5 years ago when I decided I didn't want to buy my first Parks on the Air antenna, portable antenna. I wanted to design one and put it in the field because I didn't find anything I really liked. So I created my own. And I started to share that with a few of my friends who really liked it. So they encouraged me to write it up in a nice PDF format and share it. And the rest has been history. It's just exploded since then. So I'm happy to share that antenna as well as a couple others, including one I haven't formally introduced yet, but I'll talk about it today. So I was born in the great Empire State, upstate New York in Schenectady. Got my double E degree at Case in beautiful Cleveland, Ohio, also called the Mistake on the Lake when I was there. I've been in Silicon Valley for about 45 years after graduation. Worked at HP, Cisco, Flextronics, and a host of startups. Loved working in Silicon Valley. I didn't want to retire, but as soon as I did, I realized, oh, this is a lot more fun than working. Uh, Husband, five grown kids, six grandchildren, of which two are en route this year. So we've got a lot of traveling to do as the year goes on. But in the meantime, I love to play golf. I play bogey golf. I love to hike, and that really is perfect for backpack portable ham radio. I'm a big musician, write and compose, perform music. But my passion is Parks on the Air. I love doing that. And I apologize in advance. I am an ICOM geek, and that's a picture of an ICOM 7300, but nothing to take away from the Yaesu, given the name of this group. So we'll leave it at that. Uh, you don't have to take notes unless you really want to. Everything I'm going to talk about today is included. For example, the slides I'm using are a subset of what I call my antennas primer. And these are Google links in the cloud, which are always kept up to date. The link stays the same, but I keep updating the primer as well as the antenna PDFs with all the details, more than you'll ever want to know unless you're actually building one or multiple. So they're all in there, and and I always share them for free. That's one of the things I do. I love this hobby, and I want to give back. And so the way I give back is I design these antennas and then share the PDFs for the whole community. And it's been quite a journey. We've got over, as far as I can tell, over 2,000 worldwide users of the antennas, and that's just my email list. There's probably many more that I don't know about. So I'm so happy that it's been very appealing to many different ham radio operators. And because I think a big part of this hobby should be do it yourself, experiment, build your own antennas. It's tough to build radios nowadays. I know when my dad was a young ham, he built his own transmitter and receiver. That's what got me into it. But nowadays they package these radios, Yaesu, ICOM, all of them, they package them so well. Our big domain for do-it-yourself is antennas, and that's why I like to promote this. I am a geek, and I'm self-proclaimed, and I'm very proud of that. I spend about 5% of my time when I think about an antenna trying to look at the math and physics, but I'm very pragmatic, so I want to start seeing pictures, and so I get into 4NEC2, which is what I used 5 years ago when I designed my first antenna, and I just loved all the pretty graphics it produced, and I'll show you a few today. I'm in Campbell, California, which is a suburb of San Jose, where it's about 10 after noon at the moment. I do all my testing in my backyard. It's for Silicon Valley, it's relatively big, but it's all postage stamps. You know, it's nothing like what you guys have back east or North Carolina, Florida, maybe in the UK as well. I don't know. But I spend 80% of my time on a new antenna in my backyard, hours and hours of testing and evaluating. But in the real world, I take it out to POTA. And for example, this new antenna I'm working on now, which I call the Challenger, I've been taking it on POTA activations for the last month because I want to make sure everything that I've designed is working exactly the way I expect it. And I love getting real world feedback from the hunters like, wow, that's the loudest signal on the band. That's the kind of stuff I like to hear. So that's how I work. I'm very specific, though, about my design principles. I only focus on portable antennas, which have three fundamentals, design principles. First and foremost is performance. Again, a geek for antenna radiation efficiency. In other words, if I put 100 watts into my antenna, I want to get as close as I can to 100 watts out. And that requires looking at everything. The model helps me do that, but also I have to use my nano VNA to measure insertion loss on a lot of my components. And so in the end, I want to make sure I have at least a 90% efficiency or more on a resonant, no tuner required, resonant, one band at a time antenna. And I do that because that gives you the maximum efficiency and a predictable radiation pattern. I also believe in elegance. I like an antenna that's fast and simple to deploy, set up, and take down 5 minutes or less. I love that. I don't want complicated antennas with a lot of moving parts and pieces. And in some cases, people do build antennas with moving parts. I also believe, given that these are portable for the most part, easy to pack and transport. As I mentioned, I do a lot of backpack radio for POTA activations. I haven't tried SOTA yet, and I want to do that. But I use backpack or picnic table, or in many cases, I learned, and I never expected this when I first started sharing antenna designs, that a lot of folks in HOAs need an antenna they can kind of hide in the garage and then throw out in the yard, especially when it gets a little darker, set up the antenna, have their fun, and then take it down. And so, again, I would say from what I read in a lot of the comments I get back, emails I get back, and I get a couple dozen a day, probably about a third of the users of these antennas are in HOA restricted environments. So they love these types of portable antennas that are also high performance. So I'm going to start focused on a few fundamentals, which some of you may know, but it amazes me how many people don't understand why I do what I do with these antennas. So I'm going to talk about that. So let's look at an antenna, a resonant antenna. And when you look at a resonant antenna, let me turn on, let's see if I can do that. Turn on my little laser pointer. Yeah, here we go. When you look at a laser, yeah, you can do that, but you don't want to do that directly. When you look at an antenna, when it's resonant, it has no inductance or capacitance. It's purely resistive. And an antenna, you can think of an antenna as basically at this point, when it is resonant, as two big resistors. One is a good resistor. We like radiation resistance. The other is a not so good resistor. That's loss resistance. And this is the one that fools a lot of people. So the radiation resistance is a total power radiated as waves in all directions. That's the productive energy. The loss resistance includes everything from the insertion losses in your components. That's why I love to measure them, insulators, loading elements, but most significantly, ground losses of the antenna current return circuit, in other words, your radials or your counterpoise, and the ground absorption in the near field. That is wasted energy. And let me tell you, I would probably guess that 80% of portable ham radio operators are wasting a lot of potential radiated current because they're not taking steps to avoid that, which we'll talk about. So, how do you measure efficiency? Simple equation. It takes a lot to derive it, but in the end, it looks just like this. It's very simple. Radiation efficiency is dependent upon the sum of those two resistors, and they're in the denominator. And in the numerator, you just look at the radiation resistance. So obviously, looking at this equation, you mathematicians out there in the audience say, if I want to maximize my efficiency, what do? You minimize your radiation or your loss resistance, or you increase your radiation resistance, or you can do both. But the key here, the one that most of us have an opportunity to do, is to reduce their loss resistance. Okay, pretty straightforward. Can I see some nodding heads there in the audience? I see some nodding heads, and I don't mean they're falling asleep. Not yet, anyway. All right, so
Question.
let's.
Can I just ask a quick question
You may, Eric. Go
on
for
the
it.
loss part of it? Is that where you get I'm thinking of my antenna analyzer where it lists capacitance, inductance, and that sort of thing. Gosh, I don't have it in front of me. Whatever
Right.
those are, the units are for that. Is that go into radiation loss if you have something other than the radiation resistance?
Yeah, the answer is not in this case. No, because what we're looking
Mhm.
at is a purely resonant antenna with no inductance or capacitance. Now,
Mm.
98% of the time when we measure our antennas in the field, we're going to have some inductance or capacitance, or in some cases, a combination of the two, depending on what the antenna is. But for the most part, that isn't part of the equation. That's part of your
Okay.
impedance, right?
Oh,
Your
impedance.
Yeah, your analyzer is looking at impedance, so it's looking at now J is an imaginary number. It's a square root of
Hmm.
-1. X is your reactance, which is either capacitive or is inductive.
Hmm.
So this is just looking at the loss resistance, which is your loading components, your insulators, but most importantly, your ground losses, which we'll talk about.
And is there a way to calculate that radiation loss?
Wow, it's amazing how you just set up the next slide. So there was a much smarter person than me, John Oppenheimer, about 10 years ago. You can't measure loss resistance directly. Now, again, we're talking about a resonant antenna. We're not necessarily saying there's a lot of inductance or capacitive in the impedance, but let's keep it simple. You can't directly measure it, but you can measure your feed point resistance or impedance, and you can calculate, it's a very complicated equation, but you can calculate your radiation resistance. And if you subtract that from your feed point resistance, you can get loss resistance. So John, later Tim here in the UK, did a great job of measuring how much ground radials take away from your potential radiation of the antenna. It's far more significant than I think anyone ever realizes. And he did a beautiful job putting this analysis together. So let's suppose, and I see this a lot of times at POTA, uh, they have a ground mounted quarter wave vertical. In other words, the feed point is basically a couple inches off the ground, and they have two ground radials, one in opposite directions. So it's 180 degrees of omnidirectional coverage. And they get a great SWR. It could be 1.01, it could be 1.1, but it's beautiful. And they say, fantastic, isn't that wonderful? No, it's not wonderful if you're a radiation geek, an efficiency geek like I am. And just look at the equation. Let's take that same efficiency equation. Now, for all intents and purposes, trust me that a quarter wave vertical monopole is got a radiation resistance of around 37 degrees. That's just a known fact. It can be derived. It's like 2 or 3 pages of calculations I won't get into, but trust me, it's about 37 degrees for a quarter wave antenna. When you plug that in, let's take a look what he discovered, what John discovered when he started measuring the loss resistance of radials on the ground, not elevated, but on the ground. So they're capacitively coupled to the ground. Those two radials only have a ground loss of 85 ohms. You go, 85 ohms? That's hardly anything. Well, plug it into the efficiency equation. Here's your radiation resistance of 37 on the numerator. You put it in the denominator, 37 plus that 85 ohms. What is the radiation efficiency? It's 30%. You put in 100 watts, so that very happy portable POTA person puts in 100 watts. He's got a 1.1 SWR. He says, this is great. He's only radiating 30 watts. Will he make contacts? Absolutely. Will she feel really good about the at the end of the activation that they made contacts? Absolutely. Could they have made more contacts, maybe even further away, if they had a properly designed antenna? Yes, they could. So let's take a look at what else comes up. As you increase the number of radials, of course, the ground losses, I know it's not intuitive, but the ground losses actually go down because you're providing a return current back to the feed point. So you're losing less of the radiation potentially into the ground. But it takes over 30 radials, in fact, 32 radials on the ground to get at least a 70% radiation efficiency. Let me say that again. It takes at least 32 ground radials to get better than a 70% radiation efficiency or 70 watts out. So that's not probably too practical for portable operators. For a home station, 32, heck, 64 radials. Even better, bury them in the ground. You've got a great quarter wave antenna, but that's not practical for portable use. But here's the kicker. When I started running computer models about 5 years ago, and I read about elevating radials, and I think it was the 1937 ARRL antenna manual. They talked about elevating radials at AM stations and how much better they worked. When I ran these models with just two elevated radials at 36 inches off the ground, including an elevated feed point, I was measuring about a 4 ohm loss resistance or 90% radiation efficiency. So therefore, what is this telling you? Two elevated radials about a yard off the ground is equivalent to, let's see, where are we down here? Somewhere around what, 70, 80 radials? I mean, it's on the ground. It's amazing. So let's look at some other research. And this is why I'm bringing this all up, because I found all this research at the time thinking to myself, wow, this is amazing. Why don't more people do this? Another gentleman who you may have heard about, he's written a lot of articles in QST, another brilliant ham, Rudy Severance in Six Land. He looked at 40-meter band. So this chart, you look at the x-axis, that's the number of radials on the ground. The y-axis is he actually looked at, and he measured, I think it was about a wavelength away from the antenna. He measured the gain from that antenna at all these for all these different radials, going from 4 up to 64. And he graphed them. And what he found was going from 4 radials on the ground on 40 meters to 64 radials on the ground on 40 meters, he could get a 6 dB or S unit radiation improvement. That's pretty significant. I'd say that's why you want to have a lot of ground radials if you put your radials on the ground. Then he said, let me try something different. In this case, the x-axis is not the number of radials. He's keeping the number of radials constant. So he says, let me take that same 4 radials and let me start elevating them above the ground. And this is, sorry for the UK friend, this is in feet and inches. No, you don't do meters, do you? You guys do feet over there. This is in feet above the ground. And again, the y-axis is the same gain improvements in dB. And he uses his 4 radials on the ground as his baseline. And he found just by raising them up a half a foot, he could get another 5 dB gain improvement. In fact, when he get them up, again, this is on 40 meters, when he got them up to 4 feet above the ground, he could match and slightly exceed with, again, just 4 radials. He's not increasing the number of radials. He's just elevated them off the ground. It matched 64 radials on the ground in terms of gain improvements. Think about that. 4 feet above the ground, 4 radials matched 64 radials on the ground in terms of radiation gain. It's amazing. I love that. So why does that happen? Well, I think you all know this. This is a typical dipole, and a typical dipole or half wave antenna, in this case, it's horizontal. It can be horizontal or vertical. Where is your maximum current? It's at the center. Where's your minimum voltage? At the center. At the ends of the antenna, it's high impedance, so that's when your current goes down and your voltage goes up. And when you're resonant, you have this beautiful standing wave of both current and voltage 90 degrees out of phase. As I mentioned, when you're at a dipole, your current max, and I want you, when I say current, to think of current equals radiation, because that's what it is. You don't radiate, voltage doesn't radiate, but current radiates, is at the center of your antenna. So in a half wave, it's about 73 ohms at the center, or if a quarter wave with radials, as we know, is about 37 ohms, where the voltage maximum is at the ends with high impedance. That's also the radiation minimum. So when you put your radials on the ground, and it starts right around here, your radial, because that's the other half of the antenna, you have high current directly on top of the soil. And what's going to happen? The Earth looks like one big fat resistor. It's going to suck up that radiation. And as you saw a few charts ago, you're going to have very low antenna efficiency. So that's why you want to keep your radials up in the air and not on the ground because of the other half of the antenna. If you take an off-center half wave or an end-fed half wave, you're moving that point down the antenna line where there's much less current, especially with an end-fed half wave. And so you can have your counterpoise on the line on the ground and not have any bad issues associated with your radiation efficiency. Okay? Does that make sense before I get into the antennas? Anything that doesn't make sense to anybody there?
Question, you said if you feed it at the end or on an off-center fed, it's okay to put the radials on the ground without losing a lot to the earth.
Correct. However, it's
Okay,
not a radial, it's a counterpoise, right?
counterpoise.
Yeah. Yeah. If we want to be sticklers about it. I mean, there's been arguments about is it a radial? Is it a counterpoise? I think everything's a counterpoise, but some people say, well, counterpoise is on the ground, radials are in the whatever. The point is you can put your wire off the transformer or the balance or the unin in this case. You can put it on the ground and not worry about it because there's not a lot of current in it. That's why it's okay to do that. But at the same time, and I'll talk about that, you also want to always, always, always elevate your feed point as much as possible on a portable antenna. If you can get it up like 3 feet, 4 feet, that's perfect because that's the maximum current point, right? That's the maximum current point, especially in a quarter wave. And if you have that on the ground's going to absorb a lot of the current at that particular point as well. So that just adds to your losses. Okay? So again, the key lesson here is your current is what's important because that's your radiation. And it's always at the center of a half wave antenna, whether it's horizontal or whether it's vertical. Okay? All right, let's get into the fun stuff, the antennas. The first one I want to talk about is what started what I do, and I call it the Performer quarter wave vertical antenna with two linked radials. Why do I call it the Performer? Well, part of my time in Silicon Valley, I did strategic marketing, and so I like to come up with funny names. So I called it the Performer, which is short for portable, elevated, and resonant. I only focus on resonant antennas. I don't believe in antenna tuners. I know that may ruff some feathers, but I don't believe in using tuners if I don't have to. So the Performer, it's a portable, elevated, resonant quarter wave covering 40 to 60 meters on a PVC ground spike or tripod. And you see here, I'll talk about these in a moment. Here's the PVC with a ground spike, and here's the tripod with two elevated tuned radials, tuned because they're elevated. When they're on the ground, they don't have to be as elevated, but you don't want them on the ground anyway. But when they're up in the air, elevated, you have to tune them. Tune them means cut for the band, roughly a quarter wavelength. Now, what makes the Performer special, and this is what really got me thinking, how do I make this omnidirectional quarter wave antenna directional? So I started modeling the radials, these two elevated radials at different degrees apart. And I came up with 90 degrees, and I'll talk about that in a minute. So I did model it extensively. The efficiency averages, the structural efficiency averages over 90% across all those bands with a very low SWR. Designed to be very lightweight, easy to deploy. I have to say this is by far my most popular antenna. It's also my oldest one, but it's been very easy for a lot of people to kind of visualize, build with whatever parts they have, and put it together and deploy it in the field and get great success with it. So what does it look like? All right, now the PDFs will give you a lot more detail. You don't have to worry about these numbers here. I'm just trying to give you a sense of what it looks like. The PDF will give you a lot more pictures. But in this case, think of this, the feed point is raised to about, in my case, I like 52 inches for this quarter wave antenna. So any kind of near field ground impact on the feed point is completely alleviated. You don't really have it up that high. I use things called Muller clips. and I attach one to the mirror mount, which is happens to be on top of that ground spike, and I have two elevated linked tuned radials. In this case, I have a segment which is a quarter wave, roughly a quarter wave for each of the bands of operation. So for example, and for 6 meters, it's 41 and a half plus 1.5, which happens to be 43 inches. Then I have a segment for 10 meters of 37 inches and so on down to 20 meters, where the final segment is 49. And these come off the mirror mount. They go out to these ground spikes. Now you can get these are fiberglass stakes. You can use those, especially those of you in the north. You can use those orange snow markers or garden stakes that you use for tomatoes, but you got to make sure they're pure fiberglass. Make sure there's no metal. The first time I ever did this 5 years ago, I had some tomato stakes, which I didn't realize had a metal in the middle of it, and I couldn't figure out why my radial lengths were so short because they were using the metal in the stakes that were in the ground at the end, so to extend the radial. So I didn't want to do that. So I learned you got to have pure fiberglass stakes. And so the antenna is basically this: you have your two radials 90 degrees apart, elevated 36 inches at the end, and that becomes your POTA performer or your performer antenna. Now, there's two ways to do this. If you want to operate on 10 meters, you've got to unhook. One way to do this is you unhook the rest of the radial, you take the stake and you move it up, and you just let the radial droop down all the way here. So you're moving the stake up for each of the band changes. When I first built the antenna, that's the way I did it because I thought, all right, well, shorter radials, I got to move the stake for each one of the band changes. And then I realized, wait a minute, there's got to be a better way to do this. So then I said, aha, one day in the field, I had this epiphany. I said, all I have to do is to come up with some way to break the continuity of the radial line at a particular segment that I want to operate on. So I came up with a couple of pieces of paracord. These are spade connectors. I put one on each end and I literally inserted them in the radial line. So let's say you want 10 meters. You don't have to move the stakes. You leave the stakes right where they are. You take this little segment, which I usually keep at the end of the line. You pull it out of there and you plug it in between the 10 and 12 meter radial line. So what does the antenna see? The antenna only sees the 6 and 10 meter radial segments, and it doesn't see all the rest of these. The benefit is you don't have to move the stakes, but you do have to move these two non-conductive segments when you change bands. And you do have to obviously adjust the telescoping whip. But a band change for me, after doing this so many times, takes me less than a minute. So for me, it's worth the convenience of doing that. Does that make sense? Any questions on that before I get into more details about this?
No question.
Yep.
The RF choke is a one-to-one
Yes.
unacceptable. Okay. I
Yes.
use one of those to keep the RF out of my headphones.
Well,
So
yes. Well, more importantly, yeah, well, yes, it will do that. And thanks for bringing that up because I should have mentioned that. It is mandatory, and I don't want to hear anyone telling me they don't have to use one. Always, always use an RF choke at the feed point, whether it's a quarter wave or a half wave antenna, because if you don't, the coax shield becomes like a third radial and it also generates common mode currents that will really mess up your radiation pattern as well as RFI, which gets back into the shack and into your headphones. So you always, always use an RF choke to literally choke off the coax so it doesn't become part of your antenna system. Okay? All right, so let's take a look in more detail about the two deployments. On the tripod, we all have tripods, and I've seen a lot of them out there in the field, and some of them are big and heavy surveyor tripods, some of them are older ones. If you don't have a good tripod, strong, strong recommendation, and I don't make money off of this, I just played with a lot on Amazon, and it's in the part list. In my PDF, I always include part lists with links. There's a Polar Duck tripod. I love it because it's so compact. and it's so lightweight and it's so effective. This is actually the older version, but there's a newer version which instead of this silver tube has two telescoping black tubes that come out of the base. I just take off the camera mount on top and it's perfect for ham radio antenna setup. And in California, they don't allow wires and trees at our parks. So I have to have a completely self-contained unit, and that's antenna. That's why I use tripods in this case. You see it, the Muller clip is right there. It's attached to one of the screws in the mirror mount, which again is attached to the tripod. And I use one to combine the two radials together at the feed point. And then the other end, each one of them also is terminated with a Muller clip, but that's attached to the top of. In this case, this is I think it's a 4 foot fiberglass stake, which gently inserts into the ground. Which, if you don't have frozen ground, is an easy thing to do. If you do, then I've seen people come up with things that kind of sit on the ground and to elevate their radials, but you can still do it. Now, the version I use and I like, but I think most people use the tripod, is I take a 40-inch furniture grade PVC tube, and I like PVC or the furniture grade because the walls are slightly thicker than the irrigation type, and it doesn't have all that nasty blue writing on it. And then I pair it with a chameleon spike, and so it does the same thing. It elevates the feed point off the ground roughly 52 inches. It also eliminates the metallic tripod, which in many cases is not an issue, except I've noticed it does have an impact on the highest bands for 10 meters and 6 meters when your radials are very short. And there is a little bit of interaction with a tripod, but for most people, it's not a big deal. At the base of the tube, I just put in a 3/8 by 24 bolt and nut, which can screw into the chameleon spike, or a flat tripod, including the Wolf River Coil Megapod. And you can still order stuff from Wolf River Coils. You just have to send them an email. At the top, I just take a 3/8 by 24 coupling nut and I screw into that. The mirror mount on a short threaded aluminum rod, which I cut down from another rod that I had. And you can see I store it with the RF choke always on it with a little adapter at the end. So I always have my RF choke ready to go on the antenna. Radials. So the radials, and I give very specific measurements. The radials are the constant. You never have to mess with those, but your antenna, your radiator, your telescoping whip, that's your variable. But these 18 gauge wire segments are all the same. And I also recommend, again, I'm not making money off of Wi-Fi, but in all the ones I've used, Wi-Fi has not only a fine crimping tool, but they have some of the best spade connectors. They also have bullet connectors. They have a whole bunch of different kinds. But I love them because they already have built-in heat shrink tubing plus internal glue. So it provides a very, very tight connection to the radial segments. And you can see over here, I have all my radials in a big loop, and I have them labeled with a Brother label maker. Also, I carry along my two non-conductive radial segments that we talked about a moment ago, which I typically store at the end of the radial line after the 20 meters. And I use a nice little Velcro strap to roll them up and easily transport them. And I love these zippered clear plastic bags, which on Amazon you see they're for travel toiletries. But I love being able to see my Wolf River coil, which I use that's a Sporty 40, which I use for 40 meters. I love seeing my radials, and I even put my Rig Expert stick in there as well. It all fits in that one little package and throw that in my antenna bag. It's an amazing antenna, if I do say so myself. And here's all the specs from the computer model for each of the bands. Bottom line, the efficiency, the structural efficiency is over 90%. The average SWR per band on the model is 1.02. Very low reflection coefficient. Anything under 20, even 30 is phenomenal. When you put the radials in 90 degrees apart, you get a directional antenna. And we'll look at that in just a moment with a front to back of about 3 dB. I mean, this is not like a beam, but it's a directional vertical antenna. It's got a peak radiation angle about 24 degrees, which isn't bad. That gives you good regional and US wide communications. And it has a pretty reasonable minus 3 dB beam width. That's where the radiated power is 3 dB less than this max particular angle of 44 degrees. So when I built the model, I came up with these beautiful charts, and I get so excited when I see these. Yeah, I'm a geek. You can see why. This is the top view. This is 15 meters on the Performer. The top view you can clearly see with the red and the purple being the strongest points of radiation. Here are the two uh, elevated radials. And I typically say your strongest radiation is between the span of those. So, for example, here on the West Coast, I point mine north and east, and I can cover Canada, all the US, and even South America, right about there. Mexico and South America, right about there. So it's a beautiful antenna for me. If you're in the Midwest, you may not want to use the directional element of the antenna unless that's what you want to do. If you're on Florida, for example, you just go the opposite to what I do. You go north and west. But you can see from the side clearly how the radiation is directed between those two radial spans. And when you look at the graphics, you can see this kind of funky looking shape. You're looking from the side now. You're looking from the side, and that's basically this down here. And the red circle is this up here. And you can see it has a beautiful SWR, easy to tune with a very low reflection coefficient. This is on 15 meters. Now that's the model. Here's reality. And I've measured these. These were actually measured at Uncle Sam 3473 at POTA Park here in the Bay Area. But you can see in every single case, almost the entire band is under 1.0, 1.2 to 1. And when you got 1.2 to 1, that SWR implies a 99.2% efficiency. So anything covering the entire 15-meter band, 1.2 or better. Same with the 12-meter band, 10-meter band, a little higher, under 1.5. 6-meter band, a little higher, about 1.5 to a little bit more. But in the end, I don't recommend using a tuner, especially if I have an SWR of 1.5 or lower. Because at 1.5, you're still getting 96% of your power radiated. So don't use a tuner. There's insertion loss in the tuner. You don't need to use it unless, no, I just don't recommend you use it. I even go up as high as 1.6 or 1.7 and don't use it. Just look at the SWR efficiency at those numbers. It's very good. So many people get so hung up. I got to have a 1.0. Oh, no, you don't. No, you don't. It makes so little difference. If you're a CW operator, which I know some of you are, all you do is you lengthen the whip a little bit and you move that resonant point down to here. Or if you want to use that for your digital communications, which I see on some of your benches there, you can just lengthen the radiator. But the radial segments remain the same. Those are constant. You just have to adjust the whip. Okay, so there's the real world. Now, what happens when you change the radials from 90 degrees apart? And by the way, I did test in my model many different radial spans from like 20 degrees, but they began to interact with each other too much, all the way out to 120 degrees. By far, the optimal span between the two radials is about 90 degrees. And you don't have to take a protractor out in the field, just kind of guesstimate it visually. As long as they're, in fact, one of my friends uses his iPhone. He kind of puts it between the radials to make sure they're square at the corner. So you can do that, whatever you want to do. But when you compare a directional performer antenna, that's the red pattern, with the omnidirectional 180, you can already begin to seize what's happening to some of that radiated energy. And let's take a look at it in more detail. At 24 degrees, which is its max radiation angle, you get, when your 90-degree span, and this is on 15 degrees, about a third dBi. Now, the I is a theoretical isotropic vertical in free space. That does not exist. This is in the real world, according to the model, and I used the California ground soil connectivity as my base. you get a plus 3 dBi versus a very typical vertical antenna of about minus 0.67 dBi. Or you get about a dB more radiation at 24 degrees, which is the maximum radiation angle. When you go to regional communications, now we're talking 30 to 60 degrees off the horizon. Uh, you get about a minus 0.31 dBi on the 90 degree span versus negative 2.67 or 2.36 dB. For parks on the air activations or other kinds of situations where you want strong regional coverage, and I'm talking not NVIS necessarily, I'm talking about 800 miles out to 2,000 miles in some cases, if you're lucky, depending on conditions. That's what I call regional, from 30 to 60 degrees. But amazingly, and I have experienced this on 20 meters here in the Bay Area, I can work Nevada on this antenna, which is relatively close to California. And I'm assuming that has to be radiation somewhere around 60 degrees. NVIS is typically considered 60 degrees and 90 degrees radiation. And you can see just looking at the POTA performer with the radials at 90 degrees apart, you get much more radiation than you would if you have it in the omnidirectional. But if you're in the center of the country, unless you're looking to work the West Coast or the East Coast or somewhere in the South, people keep them omnidirectional, and you can see what the differences are here. Of course, the sacrifice on the 90 degree span is you don't get as much rear coverage that you do with the omnidirectional. In fact, the omnidirectional gets another 2.4 dB coverage off the backside. But that's what you'd expect with a 3.37 front to back at 24 degrees on a 90 degree span. Does that make sense? Any questions on the performer? Like I said, a lot more details on the parts, the pieces that are required, the links to get those parts and pieces if you don't have them are all in the PDF, including all the calculations and the charts. But this will kind of give you a taste and hopefully a teaser if you're interested in trying it. I strongly recommend you do. Any questions about the performer antenna? Wow,
So,
who's that? Oh, there's a
so
question.
Greg,
Yeah, Dave. Oh, Brian.
not specifically towards the performer antenna, but
Yep,
so I don't want to call it POTA, but we go out once a month and I use a DX Commander, the
sure.
smallest one.
Yep.
It's on the ground, the base plate's on the ground.
Yes.
I've got 6 radio points with 4 wires. So I've got 24 radios of about
Good.
feet, 13 feet coming off of them each.
Good. Good.
And I spread them out all the way around.
Yep.
Um, the antenna it's not mounted to the ground. It just sits on the ground and it's got 3 guy wires. But there is the ability to put a stake underneath it and elevate that.
Yep.
So I could potentially elevate it, let's say 4 feet off the ground.
You could. You
Given your
could.
theory, I don't need 24 or 6. There's six separate connections with 4 each. So there's 24 wires on, total. I could get away with a lot less than that if I elevate it per se.
Correct. But you need to have 2 elevated radials per band. Colin and I have actually exchanged emails. And, by the way, let me just say that's an amazing antenna, the DX Commander. Strongly recommend it. And it's very convenient in that you don't have to do anything because I believe it uses multiple parallel radiators for each of the bands. So you can just, change bands without having to go out to the antenna to change anything with it. But when you do elevate, but you can elevate the DX Commander, and I know guys who have done this. When you do it, you have to have 2 elevated tuned radials per band. 2 elevated tuned radials per band. When I say tuned, they're not exactly a quarter wavelength. They're typically a little bit shorter. Depends on your ground connectivity and that sort of thing. But you have to have 2 radials per band to make it work efficiently.
So
So
does
so
that
that
mean,
would be, on 5 bands, that's 10 different radials. So it's up to you. I mean, you can decide to do that.
right? But would you have to physically take them off and put just 2 on for each
No,
band?
no,
You can leave them all on?
no, you don't. You can leave them all on. My very first antenna, when my dad, helped me study to get my extra class license, was a butternut vertical. A butternut vertical. Remember those about 30 years ago? They were like the king antennas. And he told me at the time, I wanted to put it in the backyard. He says, no, 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 let's put it on the roof. You want to elevate your butternut and then put the radials on down the sides of the roof. So they're kind of almost drooping down a little bit at a slight angle. He says that's the best kind of antenna. And we elevated the vertical, which I think that one I don't think I didn't get the 80-meter coil. I had the 40-meter coil on it. Yeah, 40 through I don't remember if it had six, but the point is what I had two radials per band tuned to that particular band opposite each other for each of the bands. And the RF finds the best least impedant path to both in the radiator and also in the radial. So you don't have to worry about that. You can leave them all on. Then you don't have to touch your antenna. That's what I would do if I had a home vertical antenna. I use an EdFed half wave at home. In California, we just don't have the space for all those big, beautiful antennas. But I would put it on the roof of my house to elevate it and get an amazing DX antenna.
Well, my home vertical is a high gain that uses the same philosophy. It's an AV620,
Yep,
so 6
yep,
through
yep,
20. And each one of those sides are a different radial, and you adjust those up and down.
yep,
The difference being my DX Commander's wire, and these are aluminum, but
exactly.
same philosophy.
Yeah, yeah, exactly, exactly. And again, the DX Commander is an amazing antenna. I love it. But for a portable antenna, I know guys that take it out on POTA. It's a lot of work. It's a
10
lot of work.
minutes. 10 minutes from the time I get out of my car to the time I'm up and running.
That's not bad. That's not bad at all. I thought it'd be longer than that. I know this takes me 2 minutes. Yeah, Eric,
Greg,
go ahead.
a question here. I just wondered, I had to take a phone call a while back.
Yeah,
Did you
sure, no
say
worries.
something about the length of the radials for different bands? I missed that part. Sorry about that.
On the performer,
Yeah.
yeah, remember, let me go back a few slides here. Let's see. Can I do it? Let's see. I think I have to click on this and do it this way. Yeah. Boop. Oh boy, here we go. Well, I tell you what, let's just look at this. Let's look at this.
Yeah.
See, the counterpoise
Or
for each of the
counterpoint.
bands is a different segment. And
Okay,
you can
it's a different
see,
thing.
yeah, so for 6 meters, it should be roughly 43 inches. On 10 meters, it should be 80 inches. But you can see they're not quite, if you look at 234 divided by frequency, they're a little bit less. And there's a lot of reasons, and I explain why in my PDF. I won't get into it here. Um,
Hmm.
but it's a little bit less. So if you build the performer, I already have this figured out for you. You don't have to,
Hmm.
play around with it in your backyard. The only thing you have to mess with is your radiator. And I give general lengths for each of the bands,
Hmm.
but depending on one, the soil you have and your part of the country and your near
Right.
field surroundings, these are going to change.
Yeah.
These do not change. So, for example, just one other point since you brought it up, Eric. If you
Hmm.
look at 80 and 43, what is that? 37 inches difference between the two. 37 inches becomes the 10-meter incremental segment that I plug into my 80 into my radial line. So you don't need to have another set of 80-inch
All
radials.
right. You
You just
just
take
plug
your
it in.
43 inches, you plug in with the spade connectors a 37-inch segment to get the 80, et cetera, all the way on up to 20.
And there's no loss in the connection, I
No,
guess, to
no,
it.
it's
Yeah.
not.
What I
It's
was
very little.
wondering is because I have a Pac 12 antenna and I have a 17-foot radiator for it. So I
Yeah.
was thinking I could put it on the tripod and I've
Yep.
got some, I think they're 30, somebody gave me some 33-foot counterpoises. So could I just elevate those and leave them at that length or should I
Yeah.
compute
For
the length?
for the 20-meter band,
Yeah,
yeah, for 20 meters, they're not going to work well for the other bands when you
right.
elevate, right? But when you
Mhm.
elevate those, yeah. Now, in my case, uh, let's see. Alexa, how many feet is 198 inches?
198 inches is 16 feet 6 inches.
Okay. So you want 16 feet 6 inches in my particular case to elevate because I've got two radials. You're not going to need 33 foot radials when you elevate. They got to be quarter wave tuned, which is about 16 and a half feet in this case.
Each radial is 16 and a half feet
Yes, yes, sir.
on 20. Mhm.
Yes, sir. Yes, yes, yes.
So Greg, do you just mount them opposite direction if we're, because Eric and I are both in Illinois.
Yeah,
So
yeah.
instead of the 90, do you just put your radial one off each side, or how do you do that?
Yeah, yeah. You put them opposite each other.
Okay.
Uh, and it just here you go. So, I mean, you don't get this you don't get this extra dB of forward gain at 24 degrees, but you also get perfectly omnidirectional coverage. And quite frankly, most of the guys that I know that live in Michigan, Wisconsin, Minnesota, Illinois, even Texas, they do it omnidirectional unless they want to work part of the country. In fact, I know guys that they're so convenient. They first start. I know this guy in Texas. He tells me every POTA activation is the same. He starts off pointed north and east, so he gets the eastern half of the U.S. earlier in the day when they've got their sunlight. And then uh, at some point, maybe 1 o'clock or something like that in the afternoon, he'll flip them. So there's one north. He just takes one and makes the other one go west, so he gets the west coast. So he still takes advantage of that gain. It's up to you. You can do whatever you want. If you just want a regular omnidirectional antenna, highly efficient, you just put them opposite each other. And it doesn't make any difference what direction they're in, as long as they're opposite. Any more questions on the performer? Okie doke. All right. So, Bob, how much time do I have? It's almost 1 o'clock West Coast time.
As much time as you need. Go ahead.
Are you sure?
Oh,
Okay.
absolutely.
All right. Well, people can dump off if they're not interested. But now let's move from a quarter wave to the halfway vertical. And I love halfway vertical antennas. I just love them. And when Chameleon came out with that 25-foot whip, oh, I was in heaven. But let's talk about what I call the Challenger and Dominator. Now, the Dominator has been out for about 3 years now. I put a Dominator together when the solar cycle began to accelerate, and I wanted to take advantage of DX on the upper bands with a very low angle of radiation. And then I recently just came up with a Challenger, and I'll talk about that too, which I'll be putting together a PDF this month and sharing that. And by the way, I do keep and maintain an email list. I call it the Antenna Geeks email list. If you're interested on any updates on my current antennas, as well as future updates on future antennas, I only send out about 3, 4 emails a year. If you want to get on my list, just send me an email. My QRZ has my correct email address. Okay, let's look at the halfway verticals. Now, just for fun, because again, I'm a geek when it comes to math and physics, let's just take a look at what happens to radiation efficiency when you dramatically increase. Remember, I talk about the radiation resistance for a quarter wave is 37 ohms. When you dramatically increase the radiation resistance of the antenna, for example, in an off-center fed, it could be 200 or 450 ohms. For an ed fed, it could be 2450, or if you have a 56 to 1, it could be 2800 ohms. When you just increase the radiation resistance of the antenna, some amazing things happen. Let's just take the worst possible case, and you wouldn't do this for a half wave antenna, but just to kind of give you the idea to make the point. With 104 ohms with one ground radial, you get 26% efficiency on a quarter wave. Now, it will work. I'm not saying you can't do that. You'll probably get a great SWR, but you're only radiating 26 watts if you put in 100. Or if you put in 10, if you're QRP, you're getting 2.6 watts out. But look what happens with the law of big numbers as you increase the radiation resistance in the denominator and the numerator. That same 104 is 66% if you're off center fed, or 96% if you're end fed. The point of that being is those aren't real calculations. That's just giving you a mathematical sense. that, remember I said you have two elements of efficiency. You either want to reduce your loss resistance or you want to increase your radiation resistance. This is how you increase your radiation resistance. Now, that's just mathematical. In reality, when I did my own field testing as well as computer modeling, I found that a single counterpoise wire on the ground, while drooping down from an elevated feed point, and even the end of it kind of laying on the ground, it ranges from 12 to 25 ohms. Why is that? Remember what I told you about current. You have very little current at the end of your counterpoise. So it really isn't getting absorbed into the ground. And I tested that not only in my computer model, but also in the field. It's very efficient. So let's talk about that. I have a Challenger and Dominator. They're both half-wave vertical antennas. The Challenger is the off-center fed half-wave for 20 to 6 meters. The Dominator is an end-fed half-wave for 17 to 10 meters, and I'll talk about these in more detail in a moment. They both sit on a tripod, no spike in this case because of the big whip, with a feed point about 3 to 4 feet off the ground. I like higher the better. I typically get about 48 inches, but you do what works for you. Again, I've computer modeled these extensively, and they're also structural efficiency are over 90%. The insertion loss, though, associated with each of these components does play a role in the efficiency of your antenna, and I'll talk about that in a moment. This is the Challenger. You can see it's got a nice, you may recognize that LDG 4-to-1 unun, not balun, because you have an unbalanced coax to an unbalanced antenna, unun, not balun like you use in a dipole. And in this, I'm using the 1010 as 49-to-1. The reason I love this polar duck tripod, the thing goes up to 78 inches if you wanted that, because you have 3 extensions in the legs. You've got this telescoping tube in the middle, but it folds up really, really tiny. I think it's about 21 inches, 22 inches. And you can see here's the Chameleon 70 or 25-foot whip. And I pre-mount the impedance matcher onto the tripod. In this case, the LDG 4-to-1 or the 1010 is 49-to-1. So I'm all set to go. This sets up even faster than the Performer. And I'll talk about those two antennas here in a minute. When you use the off-center fed, the LDG 4-to-1, it's matching about 200 ohm impedance. And so I typically use like a bolt instead of a coax connector SO239. I use a bolt and a ring terminal at the end of a 12-inch pigtail. And that 12-inch pigtail serves it serves two purposes. One, it connects the radiator to the transformer, or in this, well, I guess you call it a transformer. It's an unun positive. But it also gives you an extra foot, an extra length, an extra foot that's part of your radiator. And because there's not that much current here, it doesn't impact the radiation pattern, but it does give you another 12 inches of electrical length. So this 25-foot whip can actually become a 26-foot whip if you want. It just allows me to not only connect it, but allows me to use less telescoping sections on top of the antenna. The counterpoise, I pre-attach a 6-inch pigtail, and I keep my counterpoise in the bag, so I can just then, when it's in the field, I just click onto it at that particular point. And as I mentioned earlier, you have to have a RF choke, not only for a quarter wave, but for a half wave. In this case, it's the same fundamental reason. You don't want your coax to become part of the antenna system. You don't want the shield to pick up common mode currents to kind of mess up your antenna, as well as RFI back in the shack or at your rig. The only difference between the Challenger and the Dominator is the impedance matching component. This uses a 4-to-1 unun on the Challenger for off-center fed. The Dominator uses a 49-to-1 transformer to match the high impedance of an end-fed half wave. And yes, the radiator lengths on the 4-to-1 are going to be shorter because you're moving in from the end than the radiator lengths on the 49-to-1 transformer. But in both cases, they use a link counterpoise, different lengths, which I'll show you. They both use a choke, and they both sit on the tripod. The Challenger, and again, these are all in the PDFs. Well, the future PDF for the Challenger, it's coming, but these are the incremental counterpoise lengths, and I will droop them down. You can see this picture here. They droop down. There's a 6-inch pigtail. When I get out in the field, I just plug in the counterpoise for the band I want to operate on, and it droops down. Gosh, what is that? About 4 feet, roughly a 45-degree angle, roughly. And then the rest of it just lays on the ground. And that's fine because there's very little current at this point. Very, very little current at this point. For the Dominator, it's basically the same thing. The Dominator, I keep the 6-inch pigtail and then the counterpoise wire attached to that. And again, all these measurements are in the PDFs.
And you're using a single counterpoise, is it?
Oh yeah, absolutely. Absolutely. Now, for a quarter wave, you have to have multiple radials. In my case, 2 elevated radials. For a half wave, you don't need that because it's not technically the other half of the antenna. You just have the counterpoise wire on the ground. You don't have to elevate it. In fact, it doesn't work too well to elevate it. I experimented with that. Now, if you're a geek like me, you care about insertion loss. Most people don't think about this. I think about this because I remember one of my design priorities is to have the most efficient antenna I possibly can. If I put in 100 watts, I want to get at least as close as I can to 100 watts coming out of the radiator. So I took my Nano VNA and I started measuring insertion losses, which translate to efficiency. I was amazed and I'll be very honest, amazed because LDG does not publish insertion losses. But when I measured it, now you have to have 2 of these units. You put them back to back to measure your insertion loss, and there's a reason you do that, which I won't get into. But I measured this 3 or 4 times to make sure I got it right on 3 or 4 separate days. It only has a 0.34 dB insertion loss. I expected it to be closer to a dB, but it's only 0.34, which relates to about a 92.4% efficiency. It's got an FT 140-43 mix toroid in it. These little Palomar chokes, I strongly recommend these. They pre-wrap these. They do a beautiful job at putting them together. It's only $30. The insertion loss is only 0.12 dB or 97.3%. So the combination of those two, you only have an insertion loss of less than a half a dB. That's very, very little. That's better than many tuners you have to use on non-resonant antennas. Much better, actually. Now, if you're a geek and you really want to squeeze out every last bit of power out of your antenna, you can upgrade the Unknown to a Palomar, they call it the Bullet 4U100, to get another 1/10 of a dB less insertion loss. Again, it costs twice as much. Some people would say they're not going to do that, but I do it because that's the way. It uses a dual port ferrite bead instead of a toroid. And they have this amazing upgrade from this toroid type of choke. They have a ferrite bead mix 31. Again, it costs a little more than double, but the insertion loss is about the same. The difference is the noise reduction is minus 42 dB, which is amazing, versus the 32 dB. So that means the rejection, the common mode current rejection is very significant in this particular one. I love this. When you add those two together, it's about 0.35 dB of loss. So I call this the Challenger antenna. If you want to upgrade it and be as geeky as me, I call it the Challenger Plus because it gives you another 1/10 of a dB less insertion loss. Now, this is the one that I think everyone knows, I hope. A 49-to-1 transformer isn't the most efficient device on the planet. The one from 10tennas, which you can buy on eBay, is one of the best I've found. Minus 0.96 dB, that gives you about 80% efficiency, right? You're going to lose about 20% of the power or a dB of power within it. It absorbs it, it heats up the toroid that's in it. But that's still pretty good for that type of transformer. Again, using the same choke as that one. But if you want to be a super geek like me, you can upgrade to the Dominator Plus, and I go from the 10 tennis to the My Antennas 56 to 1, which has only an insertion loss of 0.4 dB, so less than half. Very high efficiency for an end-fed half wave. In fact, I use a variation of this one at my home for my end-fed half wave in the backyard sloper because it's so efficient. And again, I use it with that very low insertion loss. Was that a question? Or is that a groan? So it could be a groan. I know. I get into a lot of the details, but I think these are important if you're interested. But let's look inside of these. Here is your LDG with a standard 140 by 43 toroid. Here's the Palomar. Now, notice they use a dual port bead. It's not a toroid. It's a dual port, which means it has two holes in it, bead inside to get the 4-to-1. And they claim that gives you a little bit better efficiency and broader bandwidth, which it does. And here is the very significant thick 1 1/8 inch bead that they use in their RF choke in this case. Here is your 10 tennis, beautifully handmade. He does a fantastic job with a 240 by 43 toroid. But look what My Antennas does. It uses a 140 by 43 toroid, but it's 1 inch thick versus a ½ inch. And the inner diameter is 0.65 inches versus 0.49 inches. They claim it's equivalent to using 3 of these for not only efficiency, but for bandwidth. And based on my tests, I concur with that. Okay. So again, I won't get into a lot of this because I know this can be a lot of detail for some of you, but I just love looking inside of these things, so I take them apart. The Challenger Plus and the Dominator Plus, the link counterpoise wires are similar. The Challenger uses that Palomar 4-to-1 dual port ferrite and it's basically the same as the LDG. In fact, it's exactly the same counterpoise for the LDG. So all you have to do is upgrade it. And by the way, if you look at this picture, this is me where I'm testing both of the Plus antennas. This is the Dominator Plus. This is the Challenger Plus on the same tripod. You can do that. You can put them side by side and take it out to the field that way if you want. And I'll show you why I do that in a moment. Because the Dominator Plus uses a 56-to-1 versus a 49-to-1, you're going to have shorter counterpoise lengths because you're at 2,800 ohms versus 2,450, so it's further down the half wave antenna line. Okay, and this is also going to be in the PDF I put out, but just to kind of give you a sense. The Challenger, and this is just the Challenger Basic, structural efficiency over 94%. When you take into consider the unknown efficiency, you already saw it's 92.4 to 94%. So it's very efficient antenna. That's why I designed this off-center fed antenna. Very, very efficient. SWR, these are averages, 1.05, reflection coefficient under 30 dB, which is what you want, at least 33 dB, at least 30 dB. Peak radiation gain better than the quarter wave. Remember, the Performer was a minus 0.67. This is minus 0.27. The peak radiation angle is 21 degrees versus the Performer 24, so a little lower, and the beam width is a little tighter. The Dominator, structural efficiency very high, over 90%, but it depending on which transformer you use. If it's the 10 tennis, it's 80.1%. If it's the My Antennas, it's 91.2%. So still very efficient antenna. Very low SWR, very high reflection coefficient. On the Dominator, this is why this thing I call the Dominator, 0.67 dBi gain at its omnidirectional at its peak radiation angle of 18 degrees with a very, very tight beam width. This is what the Challenger looks like. You can see omnidirectional. It looks pretty much like a quarter wave radiation pattern, except you get a little bit more radiation at its peak radiation angle. The Dominator, you can see how all of a sudden it gets flattened out And this little blip gives you that extra radiation, in this case on 15 meters, 0.6 dBi gain with a very tight bandwidth. So when I talk about these, oh, this is the real world. This is what you guys should see. This is the Challenger half wave, which I measured at the POTA part. You can see again, the entire 20-meter band is under 1.2 to 1, which again, 99.2% efficient. Same with the 17-meter band, much smaller. The entire 15-meter band is under 1.2 to 1. Very flat, obviously, on a very narrow 12-meter band. 10-meter band, in this case, I'm a side banner. If you're CW, again, under 1.2. If you want to work the FM up here, you just kind of shorten your radiator a little bit, and it looks exactly the same, except it's resonant up here. And here's the 6-meter band. When it's open, it gives you tremendously flat response across the entire 6-meter band. And the Dominator, again, same type, extremely broad band. This is 17 meters, 15 meters, 12 meters, and of course 10 meters. So, to summarize these antennas, Performer's a quarter wave, can be omnidirectional or directional with two elevated tuned linked radials, either 90 degrees or 180 degrees apart. The Challenger is omnidirectional. It uses a 4-to-1 Unan. The Dominator is omnidirectional. It uses a 49 or 56-to-1 end-fed transformer. The key component loss really in the Performer is just the toroid choke, which you saw is about 0.12 dB. That's negligible. You won't even notice it. The Challenger can be anywhere from 0.46 to 0.35. The Dominator, depending on the transformer, 0.1 or half that to 0.5 dB loss. But here's where the things that you're really interested in. The peak radiation on the omnidirectional Performers minus 0.67 dBi or 0.41 dBi if you put it in its directional configuration. Here's the Challenger minus 2.7, the Dominator plus 6.7. Here's where it begins to get interesting. The angle of peak radiation off the horizon, 24 degrees, 21 degrees, and lower 18 degrees for DX. The beam width, 46 degrees. Now, when I say minus 3 dB beam width, you understand that? That's where the radiated power is minus 3 dB from its peak radiation angle, okay? 46 degrees beam width, narrower 32, even narrower still 28 degrees. To give you a visual sense of what that is, this is the Performer, 24 degrees at minus 0.67 with a 46 degree beam width. Pretty darn good. But then here's a Challenger. Not only do you drop the peak radiation angle down 3 degrees, you also tighten the beam width another 14 degrees from 46 down to 32. So you're concentrating more of your radiation in a smaller span of power. And of course, the Dominator drops the max radiation down another 3 degrees with a plus 6.7 and a very tight 28 degree beam width. Make sense? Let's look at all three antennas kind of on top of each other. What does it look like? Well, let's look at 15 meters. The Performer's in green, the Challenger is in red, and the Dominator is in blue. Let's zoom in on that. At the Dominator, at 18 degrees off the horizon, you get that 0.68 dBi of forward gain. The Challenger at that same angle off the horizon is minus 32 dBi. The Performer, the omnidirectional Performer, is a minus 1 dBi. So that's why when I talk about what the Dominator is used for, and that's why I designed it, because I wanted to take advantage of the upper band DX, which is 15, 12, and 10 in particular. 6 meters rarely open, but 15 through 10, I always use my Dominator because of that extra incremental. But look what happens, and this is why the Performer is so popular. Let's overlay the directional Performer with a radial span of 90 degrees, and look what happens. Let's zoom in again. The Performer overlaid, the directional Performer overlaid against the omnidirectional Challenger and Dominator. Performer exceeds the Challenger in radiated beginning around 16 degrees off the horizon. Again, the Performer is the green, the Challenger is the red. So I'm down here. And it exceeds the Dominator at 23 degrees off the horizon for that regional coverage. And you can see that here. This is why the Performer is so popular, because when you put it in its directional configuration, you get amazing forward radiation, and it concentrates all your energy, about 3 dB more in the forward direction. So when you summarize the two, they all have very high structural efficiency, very quick deployment, easy to pack and transport. The Performer gives you 40 meters. These don't. It gives you that front to back. It's the best antenna for regional 30 to 60 degrees coverage. The Dominator has the lowest angle of radiation at 18. That's pretty near DX country. It gives you the strongest maximum radiation, a 0.67 dB and dBi, and it's the best antenna for 5 to 20 degrees global coverage. The Challenger, and the reason I created it and probably called it the Challenger, is that it's a nice hybrid between the two. It's got the highest radiation efficiency. Unlike the Dominator, you can use it for 20 meters and 6 meters. So for balanced coverage, general purpose, whether it's DX or whether it's regional, the Challenger, I think, will be an excellent antenna in the field. I've used it pretty much over the last month, and I've gotten amazing responses from the hunters that I work across the US and also on DX. Now, that could be the end of the presentation, but there's one more thing. What if you take the Dominator, and I've always wanted to do this, and make a vertical beam? What happens when you do that? Magic happens, my friends. It's magic. And you'll see what I did is I designed, and I have a PDF that tells you how to build your own. I have this PVC structure, and you basically take a second whip. In this case, this is because I want to get all the bands 17 to 10. This is a second chameleon 25-foot whip. You can use two 17-foot whips for 12 and 10 meters only. But in this case, I'm showing a 25-foot whip. And I have a parasitic director. Now, so here's the Dominator. Here's the Dominator on the tripod. You can see there's the 10 antennas transformer, and you can see the polar duct tripod. There's the coax here. There's the choke, if you can see that. Here's the counterpoise wire, which I run basically underneath the parasitic director. The parasitic director is just that. It's passive. It's parasitic. So you don't need a counterpoise. It's just another telescoping whip, which I have found 6% shorter than the radiation whip, will give you a perfect parasitic director for that particular antenna. Why parasitic? I could have built one with a reflector instead of a parasitic director, a parasitic reflector. The advantage of a parasitic director is you get a little bit more gain, you get a little bit more bandwidth, and the spacing between, because it varies per band, between your radiator and your director is a lot less than a reflector. You've seen beams before, 3-element beams. You see the director is a lot closer to the radiator than the reflector usually is. So I decided to build one, and it gets up to 4 dB gain across 17 to 10 meters. And I had to come up with a very clever design for this PVC tube structure. Again, it's all in the PDF. This is actually telescoping PVC tubes. Why telescoping? Because the distance between the parasitic director and the radiator varies for each of these bands. And I used a calculator to determine what the optimal spacing is. And I also confirmed it with my computer model. So all you have to do, and you can't see it probably, but there's a little mark on the tube that says, if you want 12 meters, put it out to that spot. Does it have to be exact? No, as long as it's close, it's fine. If you want 15 meters, you pull it out some more to here. 17 meters, you pull it out to there. And again, I show you how to build it in my PDF. And so think of it as a trombone. One of my friends calls it the trombonator Dominator, but that's what it is. And here you can see it from the side at a POTA park here in San Jose. Like the Dominator, it fits neatly in this 36-inch bag photography bag. And so this carries and gets set up in the park again very, very quickly. I'd say 3 minutes. I'll add another minute to it because you have to attach the PVC structure. And the PVC structure I designed is in three separate elements. Now, all these joints are glued except for where it comes apart because I wanted it to store flat and transport flat. So you can see here is the horizontal section. Here is the vertical section that goes from this point down to the ground, and here's the base, all flat. What does it look like? Oh, that's a thing of beauty. Look at that. The purple and red are the strongest forward radiation gain. And instead of being 18 degrees off the horizon, it actually lowers the maximum radiation angle down to 16 degrees. In this particular case, it's showing it on 10 meters. And you can see the difference of the Dominator beam in blue versus just a plain Dominator. And on 10 meters, you get close to 4 dBi gain at 16 degrees off the horizon. That, my friends, is an amazing DX antenna. Real world, flat, 17 meters, 15 meters, 12 meters, 10 meters. Every band, the entire band is 1.2 or better. So you don't even have to change it if you do CW, digital, or sideband. It's that efficient and it's that broadbanded. So in summary, you saw these three before. Here is a Dominator beam, peak radiation on average across all four bands, 3.6 dBi, 24, 21, 18, and now 16 degrees off the horizon for a wonderful DX performance. And the beam width goes from 46 degrees to almost half on the Dominator beam for 24 degrees. I call these global antennas. I call this the hybrid continental global, and I call the Performer the regional continental antenna. You don't have to take notes. I got links. It's all there. It's all available. If you want to get on my geek list, send me an email. I always provide everything I do for free, and I share it broadly within the amateur radio community. If you want to help me fund my addiction to all these antenna parts, and you're more than welcome to donate, but certainly not obligated. And that, my friends, is the end.
Thanks, Greg.
I have a
Well,
question.
Greg, I got to tell you, that's the most amazing presentation I've seen in a long time.
Oh,
Thank you
yeah.
very, very much. I think everybody appreciates it. I wish I could understand more of what you said than I do, but I think there's other fellows here who really got a tremendous amount out of this. Anyway, I thank you very, very much. Anybody else have any questions? Go ahead.
Yeah, I have a
Thank you,
question.
I have a
Greg.
question. Oh, I'm sorry.
If
I just wanted to thank Greg for his good presentation.
Thank you. I appreciate that. I try to make it simple. You know, again, I'm a geek, and so I like to get into all the, but I try not to go too deep because I know it's boring for some of you. So
Hamstring cramp.
I had a question. Are we getting an email link with the PDFs, or do we have to email you?
yeah, my email's good on QRZ. In fact, I get a couple dozen emails a day, people requesting plans for free, and people also asking me questions as they build. And I'm retired now, so this is one of my activities. So I can sit over my 2 cups of dark French roast coffee in the morning and answer my.
3107.
So by all means, I can hear someone's radio. By all means, please feel free to email me. I'll send you the links. I'll send you whatever plans you're interested in. You can download
Yes.
the plans off the links. As I update the plans, the links stay the same.
Stand by, man, Virgil.
Greg,
Yeah. I emailed you. I emailed you my email, so you email me, and I also sent you a tip for a cup of coffee. But thank you so much for the information.
Greg, if I can permit 2 observations.
Yes, sir.
I've been at this crazy hobby for 65 years, and
Wow.
I have to say,
Okay,
I sat
are you
through
there?
countless numbers of antenna presentations, and this is outstanding.
Oh, thank you.
Yeah.
It's one of the
Virgil,
best.
calling you on
It
31.
really is very informative. But I think you're also aware that GAP antenna has a vertical dipole called a Challenger.
Oh, I did not know that.
Yeah, Gap is in Elsmere, Florida, and they produce vertical antennas.
Oh,
And the main one, I happen to know because I have one,
okay.
it is a Gap Challenger.
Oh my goodness. Well,
And
see,
it's a vertical dipole.
it's a vertical dipole. Well, what do you know? Great minds think alike. You know where I got my name from? I was driving home after my first park activation with what's now called the Challenger. I was driving home and I was going, wow, this thing is amazing. I'm getting such great signal reports. I was getting 5.9s on the eastern seaboard, Georgia, Florida, all the way up to New Hampshire, Massachusetts. And I was waiting at a stoplight, looked to my left, and there was a Dodge Challenger there. And I said, ooh, that's a good name. So I just called it.
Now I got to write to you and figure out how to get a 160-meter antenna in my small garden.
Ooh. Well, if
That'd
you
be
can
it.
figure that out, let me know because we live on postage stamps. I can push I can push 160 meters on my antennas 56 to 1, but the wire isn't long enough, so it heats up really fast. The toroid does. So I have to run it, like 30 watts. I still make local contacts. It's kind of fun, but you know,
I have
160.
a question.
Question. Um, if you were, if I were to only be interested in making 20-meter contacts, I assume you could just make that
Yes.
one or those two radials the
Yep.
right length for 20 meters and not have
Yes.
all different connections in them, and it would work the same.
Yes, yes, yes. Yeah. No, I know a lot of HOA guys. That's exactly what they do. In fact, this one HOA guy I talked to last month, he says he only wants to do 20 meters at his HOA. So he didn't cut all the radial segments, spade connectors. He just cut two 20-meter elevated radials and he had his whip extended for 20 meters. And that was his antenna. He says, given that, it takes him, he said, less than a minute to set up. I don't know if that's true, but that's what he said.
What calculations are you using for the whip length?
I use the computer model. The computer model is in all my PDFs. What I do is I show the computer model that said it should be roughly this length. And then what I do is I go into the field to verify that. On the Performer, they were pretty much the same. On the half wave antennas, they were a little bit different because I used different components than the computer model assumed. But for all intents and purposes, I don't publish any telescope and whip lengths unless I test them over real ground here in California. Now, as I mentioned, your radial, not your radiator, your radial and or your counterpoise lengths are always fixed, as I've shown in my designs. But the telescoping whip will vary based on the soil. You could be over ice, you could be over rock, you could be over very fertile soil like you have here in Silicon Valley. So it's going to be very different depending on that, and then especially the near field surroundings, which have a tendency to reflect some of that radiated uh, uh, electromagnetic waves back to the antenna. So that also affects the length. But just go out in the field with your antenna analyzer, adjust the whip for resonance, and you're done. It's not that complicated.
I have a quick question for you.
Yes, sir.
On your vertical for the 40 meter, whatever, and you're using
Oh, yeah.
the Wolf River Shorty 40.
Sporty 40, yeah.
Well, that's what they call it.
Yep, Sporty 40, yep.
The Shorty 40. Now, I guess I've used the Shorty 40,
Sporty 40.
the Shorty 40, but I didn't have the bandwidth that you showed on your.
No, you don't. Oh, no, I'm sorry. I didn't show that. Yeah, you're exactly right, Keith. You're going to get a much narrower, higher Q
Right, your Q
SWR.
is right. Okay, because that was because
I didn't show that. I didn't show that because
you were talking about your little clear plastic case and you had the
yeah,
40 in there, and
yeah.
I'm looking at your graph and it just was not making sense. Not for that.
Yeah,
And-
exactly right. The SWR will not look like that. It will look more like this because it has a much higher Q. But so you just adjust the whip for where you want to be.
Right, I understand that.
Oh,
But-
and incidentally, since you brought it up, Keith, that's Thanks for mentioning 40 meters. And it works really well, by the way. I use it a lot. You can, if you want, and I didn't show the radials, elevated radials cut for 40 meters. What I do is I take the 20-meter radial pair. Remember, you have one Muller clip at the end where they come together,
Yeah.
and then you have the two radials with a Muller clip on each end. What I do is I disconnect the pair that's connected under one radial clip. I disconnect it from the mirror mount. I take one of the ends of the 20-meter radial, attach it to the mirror mount, move what used to be at the mirror mount to the center with a stick, and then take the other radial end and put it out to the end. So in essence, you'll end up with, instead of two 16.5-foot 20-meter elevated radials, you end up with one 33-foot 40-meter radial elevated. If you want to put up two 33-foot radials, you can, but for my type of park activations and such, given that 40 is basically regional coverage, unless you're in the pitch of night or early in the morning, it's a great regional antenna, and it works just fine with one elevated radial. And plus, I don't want to cut these long radials for 40
Right.
meters.
And the other thing too is, you were talking about POTA park activations.
Yeah.
Driving up to a parking lot somewhere and pulling out all your stuff out of the back of the bed of the truck. That works great as far as carrying some of the gear that you were talking about, and then trying to elevate your radials, and you have, extra poles to elevate your radials. That's all fine and dandy, but if you got to walk a trail and you got to carry some of that gear, it gets pretty old pretty quick.
Yeah, actually, the Performer, I backpack the Performer, and I have what I call a backpack version, where instead of using my two 48-inch end stakes, fiberglass end stakes, I cut them down to 36 inches so they fit in the side pocket of my backpack. And the telescoping whip, of course, is very short. I think it's also 21 inches. The polar duck tripod I use is 21 inches. So it all fits easily, including the Sporty 40, fits in my backpack. So I've done that. But you got to have space, to extend the radials elevated. And you got to be careful. You don't want people walking into elevated radials. That's another downside.
That's another major issue.
Yeah, you got to be careful. But you know what? Most of the time, that's why I use orange wire. Some people even take little light ribbons and they dangle the ribbons from them.
Yeah, I know all those tricks. Yeah.
Yeah, I've never had anyone unintelligent enough to walk into the wire. But you never know.
I have, but
Okay.
that's another thing.
Plenty of those
Jonathan.
people out there.
Yeah.
I made a career out of that.
Jonathan, it's late for him. He has a question. Go ahead, Jonathan.
Yeah, hi, Greg, and thanks again for the presentation. I've spent my professional life on a stage a lot of the time presenting stuff to people, and that was one of the best antenna presentations I've seen, as Neil said. So thank you for that.
Yeah,
it's only 9:30 here. I've now got my can of cider. So cheers to everybody on that one. I just wanted to really comments. I mean, I was also going to make the Challenger comment that Neil made, because that's quite a popular antenna over here. So people would know the Gap Challenger quite well.
Change the name. I don't know. Now you're getting nervous.
There's no problem. This is the KJ6ER Challenger. So I don't think there's any.
And it's free. You don't have to pay for it.
Exactly. Yeah, exactly. I have a friend, yes, it's typical, isn't it? My friend who's got this complaint. But I have a friend, Kevin, 2E0WMG, over here, and he goes to a lot of islands. He goes out POTA, but he also goes kayaking with radio and stuff. So he's really into this sort of the two, apart from the performance bit, he likes that as well. But particularly the two other objectives you had, which was to keep it, elegant and to keep it quick and simple and whatnot. And a lot of the time he's going on, on boats and things, so in waterproof backpacks and bags and the wet bags and things, dry bags, in order to get his stuff to wherever he's going
right.
dry. So the sort of compactness of what you were saying, he would be very interested in. I wish I'd known exactly what you were going to talk about tonight, because I'd have tried to get him here. So with Bob's permission, I'll give the link to this guy so he can look at the recording of the presentation, and he may well get in touch with you
Of course.
Subsequently. I know he's done a lot of experimentation with things, particularly raised
Points.
elevated radials, because we did a lot of projects in the club here about the benefits of that. So I completely concur with what you said on that. The other thing he's tried doing is the vertical dipole arrays, which is sort of getting towards where you're going with the sort of parasitic elements and things, with the other one. So I don't know whether have you played with any VDAs at all? The other thing he finds himself doing is on beaches where obviously the ground. You mentioned the difference in ground. If he's got sand and then seawater underneath, that's pretty.
Amazing.
Pretty damn good. So he doesn't need a huge amount of it. He gets away with some inefficiency in his antenna because of the takeoff he's got with the salt water. But yeah, just any comments really you had on both the ground situation there and also the VDAs.
Well, first of all, Fresnel effect. You all know what the Fresnel effect is? The Fresnel effect is what happens within a wavelength or two or three or four of where your antenna is. And the reason that the Fresnel effect is so important is because when you're on the beach with salty sand and salty water, you get an amazing high, if very efficient reflection off the water. So you send definitely more signal out. So you dramatically increase your antenna because when your signal bounces off the ionosphere or off the ground, you're going to lose power the more bounces it makes. So if you can get the Fresnel effect going in your favor, where you bounce off the ionosphere and it bounces off the salt water, that is amazing. As far as the arrays, I haven't, other than the parasitic director, which for me is the best because I thought about doing a lot of different things, but using a parasitic director is a very simple and efficient way for a vertical beam, if you will, in this particular case. However, I have played with quarter wave arrays. And in fact, when I first started Parks on the Air about, again, 5 years ago, before I really invented the performer, my friend and I would take a quarter wave array, two vertical antennas. You put them either in phase or out of phase, depending on, I think we had a quarter wave coax going to each, and then we insert another half wave coax into one of them. And that changes the direction 90 degrees, either north, south, or east, west. So you can flip a switch. When you switch in that extra half a wavelength of coax, it changes the phase. And so they radiate in the other direction. And you get, I think it's another couple of dB of gain. So it was very effective when the cycle was at its low point. But that's the only type of arrays I played with.
Okay, thank you very much, and thanks again for your presentation. By the way, you mentioned the butternuts. I use a pair of those here at Fixed Station. I've got an unusually big amount of land here compared to most UK stations.
Oh yeah.
So I've got a strip of land that's very long and narrow. So I put two butternuts like that and phase them with a quarter wave thing between them, and it works nicely for DX on 80 and 40. It works really nicely.
Oh, I'm envious. Amazing. Good for you. Good for you.
So, Jonathan,
we live on postage stamps here in Silicon Valley. A quarter-acre lot is pretty massive. It's also
most places over here are on housing estates, and they're not anything like what I bought this place specifically because I do radio.
I like to stop sharing. Yeah, here we go. Sorry about that. I was sharing my end page. Yeah. Exactly.
I had a couple other things.
Keith.
On your, you were talking about your efficiency, and you were showing your efficiency with the number of radios that you double, quadruple, and so on and so forth. And then you talk about 90% efficiency when you got two radios out. So that was one thing that I was kind of curious about. The second thing is, have you seen what the military is experimenting with, where they have a vertical antenna of their own?
Yeah.
What it is a saltwater water jet that goes straight up.
Oh yeah, I heard about these.
And they adjust the height of that depending on whatever frequency they're operating at.
Yeah.
But, they can move it up, move it down.
Yeah, very cool.
Force them through that pump.
Yeah, very cool. Yeah, I heard about them. I've never seen one, but I love that idea. And yeah, remember, think of a capacitor. Remember, did you ever take in high school, physics, and they tell you about a capacitor, and as the plates are moved further apart, the capacitance is inversely proportional to the distance between the plates. Well,
Yeah,
think of an elevated radial as a capacitor, right?
right.
Radial is one half of it, the ground is the other. As you move up, the capacitance, and that's the bad thing when you capacitively coupled your radial to the ground, you get a lot of high capacitance and a lot of loss. But when you raise it, I'm trying to stay within the view of my camera. When you raise it, you get very little capacitance or negligible, and so you
Right.
increase your efficiency.
Yeah, I went through physics and everything else in school. Electronic engineer by trade. Also, the other thing that I was talking about or playing with, I have property in Tennessee in the mountains, and there's nothing but shale
Oh,
under the red clay, red dirt, whatever you want to call it. But it's shale.
yeah.
So, I sat there and experimented with stuff out in my yard and went to a few POTA parks around here,
Yep.
and it worked all great. Then
Yep.
when I went out there, I ended up hacking my radials apart because the difference with the shale in the ground.
Yes.
I'm on a
Yes.
mountain. So now I have two sets, one for here and one for Tennessee when I'm playing in the mountains.
So you just exactly right. The ground has a huge impact. The type of ground
Oh,
has a
yes, it
huge
does.
impact on the performance of the antenna. Now, do you elevate those radials, or they were on the ground?
I've done both.
Okay, good. Yeah, if when you elevate your radials, it significantly lessens the impact of the ground, the type of ground is what I'm trying to say. So you could be on fertile ground or on shale. You'll do better on fertile, but because there's so little capacitive coupling to the ground, it won't make a heck of a lot of difference even on shale. Now, if your ground is frozen or it's rocky, you can't stick those endpoint
Yeah,
stakes.
right.
So, but I know guys. I mean, we don't have that issue in California. I've used trees or little shrubs to kind of lay them on
Right.
if I was backpacking. Or some guy actually built these little PVC stands to raise his radials with a flat base, so he can do it that way. You just got to use some ham engineering there or ham
Well,
engineering.
you talk about ham engineering. If you guys go and look on, I got the website. I'd have to pull it up, but it's Signal Core, and they do the same thing we do. They go out to the field, they set up a radio, they do their thing.
Yeah.
We play, they're doing it for other reasons, but they were in there, and I've gotten a lot of good ideas, and I've seen that, and I've done that, like in Tennessee, where they talk about how to use whether it's trees or shrubs or anything that's laying around
Yes.
or any kind of
Yes.
trash.
Yes.
And you incorporate that into building your antenna system.
Yeah. Exactly.
It's a great little read if you guys, it was done by the Signal Core because
Very cool.
they went through that whole thing.
I've even seen K8 MRD, the guy that has the YouTube video channel. He took sticks for the ends of his elevated radials, and if you tilt them just right, it balances the weight of the
Right.
elevated radial.
Wire.
Yeah, with a stick. Kind of, you got to be careful if the wind blows, but he figured it out. If you get two of them, you could probably do a pretty good job.
Right. But I mean, it's little tips and tricks that they have in those books.
Yeah. Any other questions or comments? It looks like Harold's raising his hand, or is he just stretching?
No, I've got a couple of questions. First of all, do I have your permission to share this video that I've recorded?
Yes, sir.
Okay. Other club members that we talked to about this presentation did not make it, so that's who I'll be sharing it with. I have a Dropbox account. If somebody wants access to the video, if they'll just email me at harold@n4her.com, I will gladly share the link to my Dropbox account so they can get to it. The other thing is, uh, I appreciate the presentation. Very good. Uh, I'm now got the wheels rolling in my head of how I'm going to incorporate some of this into our club POTA kit.
Good.
Uh, you know, the fiberglass, I call them engineering or surveying stakes.
Yeah.
I've got a bunch of those over here, so they will go in the next kit. So the thing about elevating the radials and also elevating, we use in the kit a Pac-12 antenna.
Oh yeah. Yeah.
So I will make a stand elevated at least 4 feet off the ground.
Excellent. And elevate, it has its own radials, correct?
Yeah, it has I think a piece of oh the flat cable where they just pull the wires apart.
Oh, yeah, yeah, yeah,
Yeah,
yeah.
ribbon
Yeah,
cable. That's what I'm
yeah.
looking
Keep
for.
in mind when they're on the ground, they don't have to be tuned, but when you
Yeah,
elevate them, they have to be tuned. And I would suggest you start with my lengths for a particular
yeah.
band. Give it a
Uh,
try.
the other little trick that I going to incorporate into it is a way of winding those up neatly. You know, make something that I consider it so it's the most efficient way to wind it
Yeah,
is I found on eBay, not eBay, but Amazon, a
yeah.
couple of kite string
Kite winders.
winders.
Yeah, yeah. I do the same thing.
Yeah.
Yeah, yeah. I've used those too. Yeah, they're really cheap, aren't they?
Yes.
You have to cut off all the kite string, though. I hate doing that, but
Yeah.
yeah. No, I've used those too.
Yeah. The other thing that, as far as I tell people about the advantage I have of making a lot of this stuff is through that door is a machine shop.
Oh my gosh, I'm envious of that too.
but
Wow.
but I have a home machinist shop over there.
Yeah, yeah.
So
That is fantastic. With all that test equipment behind you, I wish I could visit you there. Where do you live? Let's see. Where are you?
Winston-Salem,
Foreland.
North Carolina.
Oh, that's not going to work.
It's a little
You're right
long
on.
drive.
Well, I do have a sister-in-law that lives in Asheville.
Yep. That's how did she fare?
She did well. She did well. I mean, they had some damage, but they live on 40 acres. And so, the house is well protected and they did
Yeah,
okay.
it's the I think the people that really suffered the worst are the ones that lived close to the streams, where the
Yes.
all of
Yes.
the water
Yeah,
accumulated.
exactly. Yeah, they're up a few hundred feet elevation.
Yeah.
Hey, Greg,
Harold, I just dropped you a direct message with my email. Perhaps you could send me the link so I can use the recording from your Dropbox in the direct message. There, you'll see it. And I put in the main chat the link to the YouTube channel that my friend Kevin, who I mentioned, does his portable operation in case anybody's inspired by Greg's antenna talk to want to go out in a kayak or copy some of the things he does.
Oh, I see
But
it.
just to finish off the one of the people were talking about the ways of weighing things down or tying things off. When he's on the beach, he quite often fills a bag with sand,
Yep.
and that can be quite heavy enough to hold something down. And then you tie the radial to that or whatever, and it keeps it nice and firm on the ground. And especially
Yeah.
if the sand's wet, it's a
Yeah.
very good way of doing it.
Yeah. Yeah. One of the nice little features of the Polar Duck tripod that I keep promoting, but because I love it so much, it's only $40. It at the bottom of the telescope, the vertical telescoping tube on the tripod, it has a hook. And I use a bungee cord between there and the ground to hold it down. I've had it out in 25-mile-per-hour gusts. But you
Right.
can also put a weight, and it's and those gusts, only the Dominator antenna, the 25-foot telescoping whip was moving, but the tripod, because of there's no center plate, by the way, in this tripod, so you can spread the legs out really wide, so it's incredibly stable. But yeah, you do what you have to do.
Very good.
Yeah.
Where do you purchase the fiberglass ground stakes to elevate the radials with?
They're all in my PDF. I give links in this case to Amazon.
Okay, I see packages of 10 and 20 that are 8 feet tall for snow driveway markers. Is that
Yeah. No, I have the 4 foot ones and they're orange with a
okay?
little reflector on top. And it's in my PDF. So
Okay, great.
yeah, I give you the link. They're not that
Thank you.
expensive.
Are you familiar with the stealth antennas Matchbox?
No.
Never mind then. It's
Now you got me curious. A stealth
well,
antenna?
it's made by a company called Stealth Antennas,
Of course.
and it's a box. And the only reason I found out what was inside of it is because I broke it. And there's a toroid and a capacitor in there, and I don't know the values of either of those.
Oh,
Uh,
it doesn't sound very efficient, but it's stealth. I think that's their
well,
angle.
yeah, and it you sit it on the ground. It has two 5 foot radials and one 16-foot radial, and you
Okay.
use either a ham stick that's tuned
Yeah.
to the
Yeah.
frequency or
Sure.
the 17-foot whip, which is what I use.
Yeah.
So I was curious. I want to try that. I want to try to elevate that on a stand instead of putting it on the ground, and then using your that one, making the radial
Yeah.
uh, the two radials at 90 degrees and see if that does it. I don't because I wish I knew what was the guts were, but I just don't know.
Well, be careful because it may not work because of that capacitor in there kind of makes me a little nervous. I don't know why it has a capacitor. Um, unless, yeah, it usually if it's a short antenna, you have excessive capacitance, so you put an inductor in there to offset it. So I don't know what that is, but it's stealthy. It's not efficient, but it's stealthy.
Yeah, yeah.
Yeah,
I
experiment.
I use a mag mount with ham
Sure.
stick
Yeah,
uh,
sure.
about 99% of the time because it's just like, okay, I'm ready to go.
Yeah, of course.
And
It's
I've
easy.
made 45,000 contacts in the last year and a half, and six of them are with you from New Jersey.
Oh, really?
Yeah,
In South Jersey. Woohoo!
yeah.
Coast to coast.
Just check the log. Yeah.
Yeah, I always, when I got a coast to coast, you probably hear me. I go, woohoo!
Yes, sir. Yes, I remember.
That's
Hey,
funny.
Greg,
I,
real quick,
I,
just want to say a great presentation, enjoyed it.
Thanks, Keith.
Unfortunately, well, not unfortunately, but I got to jump out here because
All
I
right.
got a ham club meeting here coming up, and I
Go
got
for it. Go for it. And no, it's getting late. I know. I know Jonathan wanted to say something
yeah,
because it's late for him.
I
Keith,
got to
thank
go
you.
as well. It's 10 o'clock. But thanks again, Greg, and
Oh,
thanks,
it's my
Bob, for
pleasure.
sorting it out. And see you all
You bet,
again another
brother.
time.
Send me emails if you have any questions or need anything. That's what I do every morning. I'm happy to do it.
Greg,
Nice.
I have to tell you, Jonathan, their time, I don't know, 8, 10 hours ahead of us.
Yeah.
This is the first time he's ever stayed this late. So kudos to you.
Okay. Well, thank you, Bob, for giving me the invitation. Were you at the other one that I gave? Did you say you were at the?
Yes,
That's what I
the
thought.
Willamette Valley
Willem,
the
Willem.
X Club. Yes.
Yeah, you can see how I added new content to the
Yes, you
presentation,
have
and
quite a bit. It was excellent.
I continually do that.
Excellent. Thank you.
Okay.
Anybody else have any
Actually,
questions?
yeah, Jonathan is 8 hours difference.
Uh,
Well, it depends. He's even more than that for me. California. Thanks, Brian. I can see you waving.
No, I'm just scratching it, but I am thinking about my DX Commander. If I can elevate it and run less radials, I don't know if it's going to get any better. But it's because of all the different bands. Because the only
Yeah.
reason I like that is because I don't like to have a tuner. I use a
Right.
Yaesu 710. It's got an internal tuner if I need it, but
Sure.
that's it. So,
Sure.
and I
Yeah.
can deploy it pretty quick. But I
Yeah.
like what you did with the vertical beams, where you said there's no coax in that other antenna, is there? That's
No, it's a parasitic. It's parasitic means that it's a piece of metal that is a specific distance away. It's 6% shorter than the radiator and a specific distance away from the radiator. It's all based on physics, electromagnetic physics, and it concentrates the radiation lower and narrower.
Yeah, I like that idea. I'm going to let my friend Eric, because he's usually sitting next to me, the guy down the other guy there, but I'm going to let him build that for us with his JPAC antenna, because that would be easy to modify.
All right, Eric, sounds good. You're on now.
Thank you, though. I might try one of those antennas. My antennas is what I use for my end fed, and I have one of
Perfect.
those boxes already.
They're the best.
Yeah,
In my testing and evaluation, they're the best.
and then I use the coax with the built-in
Oh yeah.
choke on it already, so that
Make sure it has at least 5 beats. 7 is even better. 7 is, if you get 7, I think those are prefixed. You can make your own, but you want at least 7 beads in series to equal that toroid choke that I show there for $30. It may be cheaper just to buy the Palomar choke. They make exceptional products as well.
Okay. Thank you, though. Thank you, Bob.
Thanks, Bob.
Thanks,
All
Bob.
right. Thank you all.
Nice to meet you all.
Likewise. Thank you, Greg.
Send me an email.
Bob, how do we get the recording of this presentation?
Well, I'm going to have to ask Harold how to set it up. But I have recorded it. It's on my computer. Now I just have to know how to share it.
It cost Eric,
Okay.
it cost you $10.
I was going to tell Brian I'll just stand at the right distance from his DX commander and I'll be the parasitic radiator.
Just hold up your antenna. Hey,
Or
Bob,
Eric, you could also send Harold a message directly, and he could send it right to you. He's got
okay.
it also.
Hey, Bob, as far as recording, I suggest you call Alan for that.
Okay.
Because, I know Alan's always willing to help you out.
Oh, he has tremendously. I'd be sitting here with a brick on my desk if it weren't for Alan.
Yeah. I think he's ignoring me because normally he would just flip me the bird at this point in time when I took him the call.
Hey, I'm curious, Don, where in California are you from? You're muted. You're muted.
I'm in near Santa Monica, 3 miles
you're
east of
south.
Venice Beach,
You're down there. Okay, gotcha.
West LA.
Yeah. Just curious. I see. Looks like Ricky's the only other West Coaster.
No, I'm in the West Coast too. I'm north of Santa
Alan?
Barbara.
Oh, that's right. Of course you are. Yeah.
Greg, I've never made a POTA contact that's having more fun than you are when you're doing POTA.
Well, thank you. I'm glad to hear that.
It's an experience.
Have you worked me when I was with Uncle Oscar?
Yep.
Yeah. Uncle, he's not really my uncle, but he has UO at the end of his call sign, so we call him that. And he's one of my POTA buddies. We have a lot
Hello.
of Harold's on his phone. Okay,
Not
I'm gonna
much.
take off. Thank you all.
Thank you.
Thanks, Greg.